Welcome to the video for perimeter and area of similar figures. You just finished up 10.3 about regular polygons. We're going to remember a couple things about chapter 7 with similar figures. So what happens if our figures are similar and we're talking about perimeter or area? So you can use ratios to compare the perimeters and areas of similar figures, and right here is the big idea of the entire section. You can figure out what the area is or what the perimeter is given just a couple pieces of information. So if you have two figures that are similar and you know one of the side lengths, or if you know the scale factor, you know that the scale factor here would be 1 to 2, then you know a couple things. The ratio of the perimeters is A to B. Okay, so we don't even need to know what this side length or this side length is. Alright, we know that the perimeter, the ratio of the perimeter of this larger shape is twice as big. So the ratio of the perimeters is going to also be 1 to 2. The area is not twice as big because it's 1 to 2. If you think about it, if this side length is twice as long as the other, this height would be half the length of this height. So we have a couple things being multiplied by 2. So it's not just as simple as saying A to B. If you're talking about areas, think about the units in area. We're not just going to go A to B, we're going to go A squared to B squared. So our ratio would be 1 squared to 4. Alright, in other words, this triangle has 4 times the area of the smaller figure. Okay? So we'll try that in a couple different ways, but that's the gist of it. Alright? Perimeters, it's whatever the scale factor is. Think about units. Perimeter isn't in square units. Area is not going to be just same as the scale factor. It's going to be the scale factor. A to B is going to be A squared to B squared. Alright, so we'll try a couple things here. The trapezoids at the right are similar. We have to know that in order to be able to do any of this. Alright, we know they're similar. The ratio of the lengths of the corresponding sides is 6 over 9. Let's just take the simplified version of that, 2 to 3. Okay, so if we want to know what the ratio smaller to larger of the perimeters, this ratio of the perimeters is just A to B. If they already gave us A to B, then we know the ratio of the perimeters is 2 to 3. For every 2 meters of perimeter that the smaller trapezoid has, the larger has 3 meters. So we'd say 2 meters to 3 meters. Okay. When we're talking about areas, the area of the small to the large is not 2 to 3. The ratio would not be 2 to 3. Okay, so what it would be A squared to B squared. Well, that means we're going to take 6 and we're going to square it. Or we could even take 2. We could take the simplified version. That works too. 2 squared to 3 squared. And then we can see what we can get from there. This is going to be 4 to 9. So maybe I should write it including some units. Alright, but it would be 4 square meters to 9 square meters. Okay, if you're looking for the area of similar polygons, what you're going to want to do is square A and square B. Because just taking A to B does not work. The area scale factors do not work that way. Okay? So if you just have to report it, you either have to take it as it is if it's saying perimeter, or you have to square both numbers if you're talking about area. Alright, and I used the simplified versions, 2 to 3 already. You could use 6 to 9, and then you would have had to reduce, because all ratios are reduced. Okay? Same thing here. I'm going to pause the video. You can figure out here quickly what is the ratio larger to smaller of the perimeters, and what is the ratio larger to smaller of the area. I'm going to pause now. You figure it out. When you're done, you can hit play. Alright, let's go through these answers here. Since we're going larger to smaller, alright, if I know that 5 is A and 7 is B, I'm just going to flip-flop them. So for perimeters, it's A to B, but it'd really be like B to A is what we're looking for. So that's just 7 to 5. All right. We don't have if it's inches or if it's centimeters or whatever, so I'm just going to leave it this way. Okay. If we're talking about area, the ratio larger to smaller of the areas, well then I need b squared to a squared. All right. In other words, I need 7 squared to 5 squared, or I need 49 to 25. Then I would check and see if 49 to 25 simplifies. It does not, so that would be my ratio. Okay? A to b, a squared to b squared. But this time they wanted larger to smaller, so we had to flip the two numbers. All right, here's what we might use it for. It's definitely a test type question. It says the area of the smaller regular pentagon is about 27.5. Area of the smaller is 27.5. What is the best approximation for the area of the larger regular pentagon? So we want the big area. That's what we want. Well, we know we have 4 here and 10 here. All right, so we could go A and B. If you want to know the ratio between the sides, which we will need, all right, it would be 4 to 10. All right, so A to B is 4 to 10, which simplifying down is 2 to 5. Okay, if I'm looking at areas, then I'm thinking about a squared to b squared. Okay, a squared to b squared would be, let's using the 2 over 5, would be 2 squared to 5 squared, which is giving us 4 to 25. So what we have right here, we're going to take this, we need this ratio, we're going to write this as a fraction. 4 is to 25, we're really going to write it as a proportion. 4 is to 25 as the smaller area is to x. We want to know what x is. Alright, so what we have here is a ratio small to big equals small to big. If I would have had the larger area like we'll have in a second, it would be a little bit different, but we're going to set up something so we can cross multiply. So if we have it set up this way, we would have 4 times x. When we cross multiply, 4 times x equals 25 times 27.5, which gives us 687.5. Okay, we cross multiplied there, back from chapter 7. All right, we divide both sides by 4, we get to our answer. All right, x is about 171.875 square centimeters, so I would choose C. Okay, we'll try that again right away. What we need to do is figure out what the ratio of the areas is, a squared to b squared, and use that to set up a proportion. So we're going to go again. The scale factor of 2 similar parallelograms is 3 to 4. The area of the larger parallelogram is 96 inches squared. What is the area of the smaller parallelogram? Well, we need a squared to b squared. All right? Or we need 3 squared to 4 squared. So the area, or the ratio of the areas we're going to use for this problem is 9 to 16. So we're going to take that 9 to 16 and we're going to write it as a proportion. 9 to 16 equals. All right, one of these is our x over here. This time we know the area of the larger parallelogram, so that goes on the bottom. Small to big equals small to big. That would mean x goes up here. All right, and we get to do 16 times x equal to 9 times 96. All right, when you do 9 times 96 divided by 16, you should get 54. So you can try and make sure the math works out here. But what we get about 864 on this side. Dividing that by 16, we end up with 54, the square inches. So 54 square inches. We know the answer we got should have been smaller because we're looking for the smaller area, so it looks like that's a quick check we can make right there. Last one I'll show you. Alright, I guess I might have two more. So, this one, same idea, just a word problem. Alright, but during the summer, a group of high school students cultivated a plot and harvested 13 bushels. That's going to be important. Next summer, the city will let them use a larger, similar plot of land. It's larger and it's similar, so we can use this a squared, b squared stuff. Each dimension is 2.5 times the corresponding dimension. That's going to be like our scale factor. So our scale factor is 1 to 2.5. Okay? They want to know how many bushels can we expect to harvest next year. So how many bushels? That's what we're looking for. Okay? So we have our scale factor. We could even say 2.5 to 1. Okay? But what we have is we're going to end up with more. So our ratio of areas is going to be 1 squared, which is 1, to 2.5 squared, which is 1 to 6.25. In other words, you should expect for every 1 bushel, that you make, you should make about 6.25 more bushels this year with this area. Okay, so all we need to do is we're going to take how many bushels we made last year, and we know that we're using 6.25 more area. So I can do 13 times 6.25, or I should make about 81 bushels. Okay. All right, just a word problem with the same idea. Now it's the last one I'll show you. All right, so if we know this now, we know the ratio of areas of two similar figures. We know both areas. All right, that's what we know. We know both areas. We don't know any side lengths. What we want to know is what's the scale factor. Okay, so we need the scale factor. All right. So how we're going to do that is we're going to write a proportion. All right. If we know the ratio of the areas is a squared to b squared, we can set that equal to what we know. 50. Let's call this a. Let's call this b. A squared to b squared is 50 to 98. And we can do some solving here in just one moment. All right, what I would do first is rewrite this simplified. A squared to b squared. 50 and 98 have 2 in common, so I could take half of both of them. This is 25/49, which is convenient because now we have some perfect squares. Because the way we're going to solve this is take the square root of both sides. All right, which is really like taking the square root of every individual piece of our proportion. So I can take the square root here and here and here and here. And those are all things I know how to do. Because I know, as I continue down, that the square root of a squared is a, the square root of b squared is b. I know the square root of 25 is 5, and the square root of 49 is 7. So this is going to be our answer. A to b is 5 to 7. So the scale factor is 5 to 7. The ratio of the perimeters is 5 to 7. We could say centimeters and centimeters again if we want to. Okay? But this is a little short discussion about perimeters and areas of similar figures. Alright, so if you need to watch any of those examples again, let me know. Or if you have questions now after watching it, let me know. But you can grab a worksheet and you can try to get started on this stuff. Thanks for watching.